$30.
But the same rules apply. It just is scaled down or scaled up. So first of all, look at the shape of the wing. Imagine that it's a raindrop laying on its side cut in half. So we see that the top side is curved a little bit and the bottom side's more or less flat.
Yep.
Air is a fluid.
Yep.
You had a course in fluid dynamics?
I'm taking one right now.
You know about Bernoulli's principle?
Not yet.
You're going to. All right, so because this is curved, it's a greater distance than underneath, from here to here. This is called the chords.
Okay.
C-O-R-D. The air flows faster over the top of the wing. It's going to, two molecules are here and they're separated, and the guy who goes on the low road gets back here to the trailing edge at the same time as the guy who goes on the high road, but he's going a little bit slower because he's covering a less distance. And when that happens along this surface of the wing, a partial vacuum develops. And that vacuum we call lift.
Oh, okay.
And when you're riding in an airliner, sometimes if the conditions are right, you can actually see that very clearly developed. If you're riding right here and look out on the wing, you can see air lifting up, well, or smoke or fog or something. You can see it lifting over the wing.
So
this vacuum is drawing the airplane up this way. Go ahead.
lift is a type of force, just like drag is.
It's the path of least resistance. So imagine you're in a boat. Forget about airplane for the time being. You're in a boat, the boat's on the water, and you want it to turn. We've got a rudder. That's this. Forget about the propeller. This is doing exactly the same thing. Ryan, look at that and tell me which way that boat's going to turn.
Right.
Correct. And that way?
Left.
Okay, now, on a different axis set at 90 degrees to that is pitch. What's that going to make it do?
Go
I'll hold it up.
down.
Make what go down?
The whole plane?
Or no.
It's going to make the tail go down, path of least resistance. But when that happens, what happens to the nose?
Nose goes up. When you have it pointed up.
Oh, okay.
Tail goes down, nose goes up. Along the longitudinal axis, that is yaw, roll side to side. There's pitch along the lateral axis. And here, this way, look at what's happening here on the trailing edge of the wing. Path of least resistance. There, that makes the tail go down. That makes the right wing go down. Path of least resistance. The fluid hits it here and makes the right wing go down, but look, over here, the fluid hits the bottom of the wing and makes that go up. So that is a right-hand turn. Look here, see that with my stick?
The fluid hits the bottom like here?
Yeah,
What do you mean fluid?
the air.
Air. You just refer to it as fluid. And
Yeah. Okay.
Okay, so notice, in other words, these are differential. These are called ailerons. They are differential. One goes one way and one goes the other.
Okay.
It's done real simple with a bell crank.
And that's the turn of the plane.
This is a turn. Here, let me explain that a little bit more. I'm going to see the rudder, that's a right turn, and that's a right turn. So this makes the airplane skid, the rudder makes the airplane skid. We'll do that. This makes the airplane skid, and this makes it slip. Now we're going to get to the final part of flying.
does this puppy fly?
Oh yeah. It won't fly here because we need snow or water for it to fly from because they don't have wheels on it.
Oh, okay.
Yeah. All right, so now let's come here, guys. They're called wetted area. How much of a boat is in the water? Now, when we look at this airplane, right now we see X amount of square inches, feet, meters, whatever, of wetted area. Of area on the airplane that meets the air and causes drag.
Yeah.
Drag is the enemy. Now, if we come out to the side, instead of X, we got the whole side of the fuselage there. So it's maybe 3X wetted area. Causes extra drag. We don't want that. So when you're flying along and you crank the airplane into a bank like that, what happens is that this whole side of the fuselage starts to slide sideways into the turn. And when it does that, it creates more drag and drags the enemy. How do we stop that? So that the airplane is now, instead of slipping in toward the middle, imagine the tail out here, and it makes it come around nice and neat.
Okay.
We have an instrument
Is that
inboard.
because you're like canceling out the drag? No.
You're not.
You're offsetting.
You don't have as much surface area.
Exactly. Now, the same thing can happen
That's in contact with it.
if you just take the airplane out and instead of using the ailerons out here on the end of the wing, you use the rudder. So you're flying along, and instead of banking, you step on the rudder, and now the airplane skids out sideways like this. Say we're turning to the left rather than the right. And so now you've got a lot of, again, you have X plus more drag out here. And that's when it can get a little hairy. It is much safer to be banked steep than have a shallow bank and be slipping and be skidding around. The reason for that is that, remember when you built your paper airplanes as a kid?
Yeah.
And you flew them and they go up like this,
Yeah.
right? And when they die down, they start flying again as soon as they get enough airspeed over the wing. And you offset that by putting the paper clip in the nose of the paper airplane. Remember that? Mm-hmm. And then the airplane flew nice, like that. Because you moved the center of gravity forward, and you also moved, remember that lift that's going over the top?
Yeah.
You move that forward. So when we're flying along, and we start to climb, we can climb up about that steep, about maybe 15 degrees. And if we climb steeper than that, the air that's leaving this wing doesn't flow nice and smoothly over the top, it burbles.
Okay.
Which means that that lift is no longer, that vacuum is no longer there, and then gravity takes over. And if you happen to be near the ground when that happens, you've got some problems. So that's the quick course in aerodynamics. Now when we're up flying around, I'll demonstrate all that for you. If you want to. If you want to just look around, you can just look around. Okay. We want to take off into the wind, but it's dead calm here. Maybe it's a little bit of a crosswind, so we'll go up there. A little bit more about that. Airports' runways are universally called by their nearest 10 degrees of compass heading. So we're going to be taking off on runway 24. That'd be 240 degrees, which is roughly southwest. Does that make sense?
Yeah.
360 is due north.
Yeah.
And we typically fly left-hand pattern since the pilot's sitting on the left side. That's not always true. Sometimes we land making circles to the right, but we'll typically fly left-hand pattern. So what we'll do, come up here just for a second in case you want to film it. One of you guys films and the other guy rides along with me, and then trade places. On the runway there, that's called a displaced threshold, and so when we're landing, now there is a little bit of wind coming up this way, so that's the way we'll take off and land. We'll land probably touchdown right about in this area, so if one of you is out there filming it, stay right up next to the fence, and you could go down there a bit if you wanted to. You don't have to. And we'll go up and fart around, and whoever, I think Ryan was going to be a hog to go first, but that's okay, we've got plenty of time for both of you. If you want to take your camera up in here, you're welcome to do that.
Wait, what does the number stand for?
November 8867 Sierra would be the phonetic spelling.
Sierra?
If you want.
That's
Yeah,
an S.
yes.
It's not a 5.
Alpha, Beta, Alpha, Bravo, Charlie, Delta, Echo, Foxtrot, etc. S is Sierra. Beautiful. Don't hold it, buddy.